Should we start? Yeah. Okay. Good afternoon, everyone. Welcome to this hybrid NITheCS Colloquium. The speaker of today is Dr. Olugbenga Oluwagbemi. Sorry, I hope I pronounced it more or less correctly. Olugbenga did his MSc at University of Ibadan in Nigeria, and where he studied computer sciences, and his PhD at Johns Hopkins University in the US on a Fulbright research scholarship. After that, he had several postdoc positions in the UK and in Stellenbosch, where he worked with Sasima. And after which he was offered an associate professorship in the Department of Computer Science at the Sol Plaatje University, where he was until, I think, recently, and is now in the UK at University of Middlesex as a computer science senior lecturer. So Olugbenga, thank you very much for being with us this afternoon. You're welcome to start with your presentation. Thank you. But you will have to unmute yourself. Hello, Olugbenga, are you still there? Let me see if I can unmute him. Yeah.
Yeah. Good evening, everyone. Sorry, I can't hear from that side, but I believe you can hear me. All right, thank you. All right, my name is Olugbenga Oluwagbemi, and I'm here to deliver this presentation titled Towards Resolving Challenges Associated with Climate Change Modeling in the African Continent. And the outline for this presentation, we have it as follows. We have the introduction, Africa and diverse climate change problems, objectives, methodology, results, and climate change challenges and solutions, and also insights from the research. And how can the climapAfrica program contribute towards addressing the climate change modeling challenges within Africa? Climate change is a very important topic of global concern, and the reasons are not far-fetched. Climate change affects many aspects of human lives. Climate change, and these aspects ranges from the quality of livelihood, the human lives, animal lives, plant ecosystem, and so on and so forth. And this also extends towards disease transmission. So climate change has a huge impact on the entire human life and on the entire human race. And due to the sensitivity of this particular topic, climate change actually poses a great threat to human and environmental security. And this is very, very important. For instance, when it comes to environmental security, part of the environmental effect of climate change currently in Africa is about the East African rift system, the split that has been noticed within the East African rift system. And that it has been established by researchers that climate change is contributing to the widening of that rift. As we can see in this diagram, we can see the split in the East African rift system as a result of the shift in the tectonic plates. And so researchers have been able to establish that climate change is contributing gradually to the expansion of this split within the East African rift system. And what does this, what are the consequences of this particular split? The consequences is that, or the consequence is that in the near future, there's the possibility of this, the expansion, continuous expansion and split of these tectonic plates to split the African continent into two, as we can see in this particular diagram. So these are some of the adverse effects of climate change within the African continent. This has been noticed in East Africa, and the expansion is gradually going on, and climate change is contributing to the widening gap within the shift of these tectonic plates. And this, it has been forecasted that the shift might extend from East Africa down towards the south, towards the southern part. So these are some of the challenges of climate change. And other challenges of climate change is that climate change aid in the spread of diseases. The changes, the erratic pattern, the changes in environmental parameters have been contributing and are still contributing to the spread of diseases such as malaria, tuberculosis, Ebola, amongst others. For instance, Ebola can be transmitted by fruit bats. And these fruit bats, they can be found majorly in the West African region. And the climatic changes, the erratic climatic changes and climate change conditions can influence the migrations of these fruit bats from one region to the other, thus carrying the Ebola virus disease from one region to the other. Malaria, the vector that transmits malaria is Anopheles mosquitoes. They carry the malaria parasite, Plasmodium species. And temperature, environmental parameter, they aid in the migration or in the dispersal of these mosquitoes, such that regions that were previously temperate regions that are now experiencing warm weather, they now have mosquitoes that can transmit malaria. Now, these are some of the impacts, negative impacts of climate change. It has also been established from existing literature that climate change also can foster the evolution of drug-resistant diseases. And after listening to this, it is very essential that there is the need to protect and save humanity. So there is the need to protect and save the human race, there is the need to protect and save the African continent, and there is the need to protect and save the entire world. And so African researchers over the years, they have been engaging in climate change modeling research in order to forecast the transmission of diseases, in order to see how climatic factors affect different aspects of the human race and human living. But the research takes place through this modeling efforts by different researchers. So the objective of our study was to identify the challenges, that African scientists face whenever they engage in climate change modeling related research. Two, to understand the challenges and limitations of climate research within the African continent. And three, our third objective was to provide solutions to such problems, or to suggest solutions to such problems. And without taking much of our time, I'll go ahead towards describing the methodology that we adopted in achieving the objectives that we set at the beginning of the study. The methodology as follows. We have data collection as the first aspect of our methodology, and that involved searching for climate change modeling related scientific publications from year 2011 to year 2020, searching for climate change modeling related publications that spanned year 2011 to year 2020. And two, we engaged in a comprehensive systematic review of the publications that we were able to collect by following the PRISM format of screening publications. That is, we engage in systematic review of climate change modeling research publications from year 2011 to year 2020. And thirdly, we conducted a comprehensive bibliographic analysis on the research articles that we were able to identify and we were able to obtain. And I will take each of the sub aspects of this methodology one after the other in order to provide a clear overview of how we achieved this methodology. And the first one is the data collection. As I mentioned earlier on, we conducted this by searching the Google Scholar database for research articles that spanned year 2011 to year 2020. And why? Why did we engage in this by using just the Google Scholar database? Because the reason is that the Google Scholar database has a wide coverage for cross-disciplinary research outputs, according to Alakanga's 2015 and Azin 2015. And besides this, the Google Scholar database has many Scopus indexed research papers, multidisciplinary, cross-disciplinary, and also it has Scopus indexed research papers. Many of them can be found on Google Scholar database. So that was the reason why we focused on the Google Scholar database. And this data collection and the entire research took us 2 years to conduct for us to achieve the results that we obtained from this particular research. After the data collection, we engaged in a comprehensive systematic literature review by adopting some selection criteria and also adopting some keywords within the selection criteria, such as climate change, modeling, challenges, limitations, climate change modeling in Africa. And after conducting an extensive systematic literature review, we were able to focus our attention on only peer-reviewed original research publications based on different regions within the African continent. And in total, we were able to work on 10,000 articles. We were able to review 10,000 articles based on the selection criteria that we detailed above. In order to have a comprehensive overview of our systematic literature review, it would be good to have a look at a diagrammatical depiction of this review. Initially, when we started our search, we were able to identify 38,870 scientific manuscripts within the Google Scholar database, that is articles from year 2011 to 2020. We were able to identify 38,870 scientific manuscripts. And these manuscripts were subjected to screening based on the criteria that we mentioned earlier on. We screened out by title, by abstract, by the body of the paper. We were able to arrive at 10,000 papers. And by the time we applied more criteria, we were able to screen out more of the papers that did not fit into the criteria that we had initially specified. And so for reports with respect to assessed for eligibility, we're able to screen the 10,000 papers to 2,600 papers. And after screening out papers that do not have the word, that do not have the keyword of modeling, or papers or research papers that weren't based in Africa, or papers that had no limitations, or papers that were not peer reviewed, and even papers that were duplicated, we were able to finally screen down the 2,600 papers to 461 papers. And so these 461 papers were the original peer-reviewed research papers that we included in our review. And as we can see within this figure 1, the Prisma chart for the articles reviewed from the Google Scholar database spanning year 2011 to 2020, we were able to review 461 peer-reviewed research articles that were climate modeling-based research articles. And this takes us to the next aspect of the methodology, which is the bibliographic analysis. We conducted an extensive bibliographic analysis based on the 461 research papers, peer-reviewed research papers that we were able to identify all the papers to, and we tabulated the results in tables S1 to S11 of Figure 2. The tables are also freely available online because this work was published last year, year 2022, where we have these tables S1 to S11 as supporting documents for the research paper. And in order to proceed with the results of the paper, we have the first result here, which shows the number of publications per year, referencing a limitation or challenge. And we have them for year 2011, we're able to identify 14 papers, for year 2012, 15 papers, for year 2013, 47 papers, for year 2015, 50 papers. We have the highest in year 2017 with 67 peer-reviewed research publications and 61 peer-reviewed research publications for year 2020. We also had further results from this particular study. We had further results from this particular study that depicted the authorship and the contributions of African authors into each of these publications. And it helped to, from the bibliographic analysis, it helped to categorize the publications into publications that had African authors as first authors, or African authors as co-authors, or even publications that had no African-based author. And Figure 4 here shows us the author affiliations as noted from the survey and articles that included author-based, African-based authors, as I had previously explained. And we can see more of that. Now, as regards the challenges that we were able to identify from these 461 research papers, we discovered that some of the challenges that African-based climate change modeling researchers, some of the challenges that we were able to identify that they continually encounter include poor quality, discontinuous nature of observation records, and this has to do with poor spatial resolution of available data. Another problem is data limitations and observation station sparsity. Another limitation or challenges identified include lack of precipitation-related variables in mountainous regions, and this had always resulted in interpolation errors, and also lack of spatially extensively high temporal resolution, especially when it comes to utilizing global climate models such as GCM or the CMIP, which is Coupled Model Intercomparison Project, or the Regional Climate Model, RCM. Other challenges that we were able to identify from the results of this research include challenges that had to do with computational power and time investment required to run some of these climate-based models. And when it has to do with, where it has to do with computational power, many African institutions lacked high performance computing machines or complex workstations that can help to aid speedy processing of climate change, climate modeling, or climate change modeling related research. So when it comes to computational power, the advanced countries had better advantage. They have massive laboratories, massive research institutes with well-equipped laboratories with high computational power that can assist to get this climate change modeling research, to get solutions to climate-based modeling research related research questions. And But in Africa, if we look at the African continent, we have South Africa is still trying. There are some institutions that have some of these computational power related gadgets, but they are insufficient. They are insufficient. So it's a major challenge, not only in South Africa, it's also a major challenge in other regions of Africa. In some countries in West Africa, they don't even have any of these high performance machines, very strong, complex, high performance machines. And there are also challenges associated with satellite data, low spatial and temporal resolution, and clouded imagery, data that have clouded imagery. That is, those data are unclear. They are not they are not cloud-free. And that's why there is the need for cloud-free images. And also, there are other challenges. I've only been able to mention few of them in this presentation, but there are other numerous challenges that climate change modeling related research that they encounter when African scientists are conducting research in line with this particular area. All right, so in order to depict these challenges, according to Beck et al., 2019, the research discovered that missions there were only 103 stations that could provide potential relevant environmental data for the whole of African continent. You know, African continent has like 54 countries. Within each country, we have many research institutions and educational institutions. So 103 observations, 103 will not be sufficient for the total number of research institutions and educational institutions that we have in Africa. And we can see in this picture depicted on our screen, we can observe that the first one depicts, that's figure A, it depicts the atmospheric observation within the African continent. We can see how sparsely distributed they are. The second one, which is figure B, depicts the weather observation stations within Africa, while the third one depicts the oceanic observation sites around Africa. So when looking at these pictures, it gives us a clear view, a visual view of the need to address these challenges. It's a major challenge because we don't have enough atmospheric sites, observation, weather observation, and even oceanic observation sites in Africa that can sufficiently meet the needs of African researchers that are involved in climate change modeling related research. And this is a serious problem. Now, we should also note from this diagram that there are operational status of each station has not been taken into account because the information is not readily available across board, across all the networks. Now, another challenge depicted in picture is this graph, which shows it's a time series of the average number of stations used in the GPCC full data product over Africa, especially the East, the North, and this was gotten from Dinku 2019. And it shows that there's a decline in the number of stations, whether climatic related stations, there's lack of long time series, there's lack of consistent historical data, and so on and so forth. And there's also poor data quality. And these are some of the challenges that African researchers the African-based climate change modeling researchers, these are some of the challenges that they face or encounter from time to time. Now, what are the solutions to these challenges? One of the solutions is to utilize satellite-derived data for analysis. For instance, in the work of Golian and colleagues, and Tremblay and colleagues, the use of satellite-derived data can assist African researchers in successfully carrying out research with respect to climate change modeling related research. And another thing is that creating unique research avenues will also help us African researchers to be able to gain insights, to link up spatial planning and climate change adaptation using the facilities related to GIS and Earth observation data in their various climate change modeling related research. I've also taken time to tabulate these challenges and corresponding proposed solutions to some of the identified problems in this research. The first one is lack of access to available data. Awareness can be created about the right places to source for needed climatic data for African scientists. And such data can be made more easily accessible. Another problem is low financial investment. And the proposed solution to this is that investments can be prioritized, okay, with respect to financial, human, or institutional capacity, so that observation network can be created and be well maintained. You see, it's one thing for observational network to be in existence. It's another thing for the continuous maintenance, sustenance of such observational networks. Poor maintenance, as we all know, will lead to degradation of the facilities within existing observational networks. Now, the third challenge that we were able to tabulate or document in this table is low density and scattered observational network stations and Earth observational satellites. And the proposed solutions are as follows. The strategic expansion is needed for observational networks in Africa. And strategic expansion of what? Of the spatial resolution related data, or temporal resolution related data. Those are the hourly, daily, and monthly data, climatic data, and also proper continuous data quality control in order to increase the utilization of free Earth observations. And there is also the need to implement multiple avenues for data acquisition within the African continent. Another challenge is the long-term measurement of other parameters that are often missing. And this leads to missing data in some of the data that African researchers utilize to conduct climate change modeling and climate change modeling related research. So there is the solution, the proposed solution to that is that there is the need to increase the number of parameters measured, okay, in such research. Another challenge is African researchers relocating from Africa to research institutions and abroad. One, either to establish collaboration with researchers abroad. Two, either to utilize advanced facilities abroad. Three, either to relocate permanently due to frustration or lack of access to needed facilities for climate change related modeling research. And the proposed solutions are, number one, providing research facilities within African institutions and maintaining these research facilities, funding and upgrading those research facilities to keep them up to date. Two, to provide funding for researchers within African institutions on merit, that is, quality-based reward and appreciation systems should be put in place. And I mean, this quality-based reward appreciation system should be void of political fabrications, of political padding, okay? Now, other challenges that we were able to identify amongst the studies that we were able to review include the lack of capacity building and lack of developmental initiative. And when we say lack of capacity building, lack of developmental initiative, this has to do with both human and infrastructure. It cuts across human, it cuts across human infrastructure within African institutions. And this is not only limited to private African institutions, it also extends to public African institutions, public sectors, private sectors, and this has been a major challenge. And the solution we propose to this is that capacity building initiatives can be provided. And also initiatives that centers around human and infrastructural development can be established and also promoted amongst different African institutions and amongst different African researchers. And the last challenge we documented here is that there are fewer research facilities in Africa, as I previously mentioned. And that means the research facilities we have in Africa, they are insufficient, which is the truth. And so in order to address this challenge, there's the need to provide more research facilities for most of the existing African institutions and higher educational institutions. And this will assist to address some of these challenges, or most of these challenges will be addressed if all this can be put in place. Other insights that we gained from this particular research are as follows. We noticed that over the study period, that is the peer-reviewed research publications that we were able to review, we discovered that between year 2011 and 2020, over 50% of these research publications were led by 3 countries: the United States of America, the United Kingdom, and Germany. They accounted for over 50% of the published manuscripts, scientific manuscripts. And this tells us something, that African researchers, we are not doing enough. African researchers are not doing enough. And there's the need to push for more and to engage more in climate change modeling research, related research, especially amongst African researchers within the African continent. Collaborations can also be established, and that will take me to the next slide. Other insights that we gained from this study showed that, or revealed that, institutions from over 38 countries globally collaborated with African institutions on climate change modeling related research between year 2011 and year 2020. For South Africa was able to establish 22% of collaboration with the United States of America. South African researchers were able to establish collaboration with researchers from the United Kingdom, depicting 36.4% in collaboration. And they were also able to establish collaborations with researchers from Germany that depicted 13.8%. This is not enough, because there were other countries that also collaborated with African researchers. Either collaboration or African researchers had to travel to some of these advanced countries in order to gain access to advanced facilities to conduct climate change modeling related research successfully. And we have other countries such as France, Norway, Italy, Spain, and so on and so forth, that were other countries that collaborated with South African researchers. Another country in Africa that we selected, that we identified, is Nigeria. Nigeria was able to, Nigerian African researchers within the sphere of climate change modeling research were able to collaborate with researchers in the United States of America, researchers in Germany, and researchers in Italy. Okay, there were other countries that were, well, you can see the percentage is not enough. There's the need for African researchers to engage more in climate change modeling related research in order to address different climate related problems within the African continent. And the third country, because Nigeria is in West Africa, South Africa is in Southern Africa, but how about Kenya? Kenya is in East Africa. We can see the level of collaborations between researchers within Kenya whose focus is on climate change related modeling and other climate change related climate change researchers in the United Kingdom, in the United States of America, and in Germany. We can see that the collaborations, they are very minimal. So this tells us something, that there is the need for more collaborations, there is the need to improve facilities, there is the need to promote climate change modeling related research amongst African higher educational institutions. And such research has to be multidisciplinary, cross-disciplinary, and so on and so forth. And these were the extra insights that we gained from the study that we conducted. So this brings us to an important question. How can the climapAfrica program contribute to address the climate change modeling challenge in Africa? The climapAfrica program can help to organize stimulating trainings, seminars, and workshops. And some of these trainings can bring to light data sources, quality data sources, especially open sources, where climate change modeling researchers can engage, can obtain free access to quality data. And they can also have access to data that they can use to implement, successfully carry out their research. And also, climapAfrica can also help to create awareness among key stakeholders. Within the climapAfrica program, we had work groups. I was part of the work group, and we were able to collaborate on ethical data sharing and interdisciplinary and cross-disciplinary research collaborations. I was able to collaborate with other African researchers from different regions of Africa, West Africa, South Africa, and some other parts of Africa, in order to successfully carry out our respective or various research. And climapAfrica also has a group of alumnus or alumni and also postdocs that are active and actively participate in activities that have to do with climate change utilization, data utilization, the processing, and so on and so forth, amongst different regions of Africa, and also cutting across different aspects such as agriculture, such as plants and diseases, such as environmental, and so on and so forth. So this is how the climapAfrica program has been able to contribute and is still contributing to addressing the challenges associated with climate change modeling in Africa. Before closing, I would like to thank my funders. That's the DAAD, climapAfrica. I received a personal research grant from them. They are based in Germany. And I also like to sincerely thank the Okunema Memorial Trust Foundation in South Africa. I was able to secure a personal research grant from this particular trust, and the combined grant, I was able to use this grant to conduct different research spanning that spanned different aspects of climate change modeling, how the impact of climate change modeling on the investigated and as for their listening. Thank you.
Yeah, thank you very much for the very interesting talk.